Everyone, welcome back to today we are going to explore a very interesting matrix manipulation problem that looks simple at first but has a neat logic behind it. So we are given a 2D grid and our task is to pick a square submatrix of size k into k starting from a given position. So once we select that block, we need to reverse it vertically, which means flipping the top rows with the bottom rows. So this problem is really important because it teaches how to work with submatrix, index manipulation, and in place swapping, all of which are very important in coding interviews and the platform like LeetCode. So don't worry if it sounds confusing right now. We will break it down step by step. Understanding the institution, go finally implement it in C++. So by the end of this video, you will not only understand this problem but also gain confidence in handling matrix based transformation. So let's get started. So in today's video we are going to see a easy range problem. Problem number 3643, flip square submatrix vertically. So what is the question? We are given a 2D matrix grid and a starting point x comma y and the size k. So we need to reverse a k into k submatrix vertically, that means top to bottom inside the grid. So what this question means? So think of it like this. So from the position x comma y, take a square block of size k into k. So inside that square, we need to reverse the row column wise. That means top row becomes the bottom row and the second row becomes second last, like that. So it's like flipping that submatrix upside down. So it's like, so if you see in this first example, we have selected one square matrix. So 5, 6, 7, 9, 10, 11, 13, 14, 15 is our square matrix. So what we should do, we will flip the top row to bottom and the bottom row to top. So if you see the 13, 14, 15 flip into the top row. So here it is in down row. Now we have flip into the top row, like 13, 14, 15 in my top, and the 5, 6, 7 that has been in the top is now in my bottom. 5, 6, 7. So the middle row is same. So based on this k, we need to select our square boxes, right? So if you see, one example, like I'm having the grid as 1, 2, 3, 4. Let me comment it like. So the second line, so I'm having here 5, 6, 7, 8. And then what I am having? 9, 10, 11, 12. So after what I'm having 13, 14, 15 and then 16. So example, take this is my grid. So my x equal to 1 and my y equal to 1 and I'm giving my k equal to 2. So first what we need to do, we need to select the submatrix. So I'm selecting the submatrix 6, 7 and then 11, 10, 11. So I'm selecting this 6, 11, 6, 7, then 10, 11 to be one submatrix. So if I select that, I would be like 6, 7, 10, 11. So this is my submatrix. So after you reversing vertically, my grid it will change into after flip. So after flip, my grid will be changed to 10, 11 and then 6, 7. So this is how we will change this. So the final grid will be, it will be same. So what is the only thing? Here it will be changed to 10 and here it will be 11 and here it will be 6 and here it will be 7. So my final grid will look like this, right? So at first my grid is like this. So after selecting the submatrix and applying the reversing vertically, my final grid will look like this. So we'll move on to this solution. So they have given one grid matrix, then they have given one x and y, and then they have given k value. So our task is to flip the submatrix by reversing the order of x row wisely. So what technique we are going to use in this? Like we are going to matrix traverse 2D array. We are going to use the technique matrix traverse. What does means? So it traverses a special part of a matrix, that means a submatrix, not the whole grid. So we will select one matrix. So in the size they are given. So we traverse that specific part only, not the whole grid. So the outer loop will be for the column and the inner loop will be for rows. So the key idea for this technique is, so control travels using x comma y at a starting point. We will take one starting point and we will select the submatrix and then we will reverse it. So if you see, the function takes the grid 2D matrix and x and y the starting point and the k is size of the square. So we need to return the modified grid. So modified 2D grid we need to return. So by the reference. So they are given here by the reference. So we need to return it in the reference. So first, what I am going to write? So first, for int I equal to 0, I less than my k, then I plus plus. So this will loop through the column of the submatrix. So what this loop will do? It will loop through the columns of the submatrix. So if I take like I equal to 0 and it will move up to k minus 1, right? It will move up to k minus 1. So each iteration equal to, it will be one column inside submatrix. So each iteration will be one column inside the submatrix. So inside that I am writing another for loop in j equal to 0, j less than my k, right shift 1 and then j plus plus. So this loop will loop through half of the row. So this loop will loop through the half of the row. So here I am writing k right shift 1. So that will be equal to k divided by 2. So the half of row will be only loop through. So why I am using this right shift? So we want only half of the rows to be looped through. So we are writing here k left shift 1. So that will be equal to k minus 1. Because we swap top and bottom, only the half is needed. So why we are using this? Because we need to swap top and bottom. So only half is needed. So next what I am writing here, I am just going to swap. What I am going to swap grid. So grid of my starting x plus j and y plus I, comma, my grid of x plus k minus j minus 1 and then of y plus I. So here you can store this value in one variable and you can use here and you can easily swap. So this is the key step. We are going to use this in problem. So we swap the top element. So this is basically top element. So let me comment here. So the top element is this is top element and the bottom element is this. So we are swapping the top element and the bottom element. So this is basically top element and bottom element. So we are swapping the top and bottom element. So what that this means, so x plus j. So this x plus j will move from top row downwards. So this x plus j will move from top row to down row. So this k plus x plus k minus j minus 1 will move from bottom row upward. So what does it means? So here we are having 6, 7, 10, right? So the x plus j. So here we are having here x plus j. This will move this top row to downwards. So here it will swap to 6, 7. And this x plus k minus j minus 1. This will move the bottom row to the top row. So here it is changed, right? 10, 11 and then 6, 7 in the down. So what it will doing here? So it is top to bottom. It will just swap, right? So at finally what we are going to return? At finally we are going to return the our original grid. So at finally we are going to return the original grid. So now if you see, you will see one example with the iteration. So I'm taking the same example with the k value, I, j, k value will be same. So first we need to identify the submatrix. So submatrix will start from 1, 1, that means 6, right? So submatrix starts at 1, 1 because our x is 1, y is 1. So that is our starting point. So we need to start our submatrix from where the starting value has been given. So our x is y and my y is 1. So 1, 1 means, so 1, 1. So what will be my 1, 1 value in my grade? So if you see, so this is 0 column, this is 1 column, 2 column, 3 column. So here it is 0th column, 1 column, 2 column and then 3 column. So if you see 1, 1, so 1 row, 1 column, what I am having? 6. So we need to start our submatrix from a value 6. So first we need to identify the submatrix. So what's our square value? That is k. So k into k we need to find. So we need to find k into k, right? So if you find k into k, what that means? So k into k means 2 into 2 we need to identify. So we need to take 2 into 2 block. So here if you take 2 into 2 block, what will be the block? 6, 7 and then 11, 10, right? So 6, 7, 10, 11. So this will be the our submatrix. So what submatrix we are going to take first? 6, 7 and then 10, 11 is our submatrix. So what are the indexes of this submatrix? So the first for 6 is 1, 1 and the for 7 is 1, 2 and then for 10 it is 2, 1 and for 11 it is 2, 2, right? So for the 11 it is 2, 2. So the first we are writing in a first loop, right? So the first loop will be, so for first loop will be I equal to 0 and it will till run up to what? It will till up to k minus 1. So this is the column loops, right? So this is the columns loop and then here we have j loop. So that is for row. So how many times it will run? So it will run k divided by 2 minus 1. So up to this it will run. So what does it will do? It is for row. So it is for row loops. So since we have k equal to 2. So the I will be run how many times? The I will be run 0, sorry, the I will be equal to 0, 1. So this 2 will be our I value and our j value will be like only one iteration because k divided by 2 what we have? K is 2 and divided by 2 it will be 1. So 1 minus 1 we will get 0. So only one iteration is for j. So first at the first iteration what we will have at first iteration we will have I equal to 0. So first column inside the submatrix. So what it is? First column in the first iteration. So the column index we have is, so the column index is equal to y plus I, that should be equal to 1 plus 0 equal to 1. So then it will go inside this second for loop and what it will have? So it will first j will be equal to 0, that means the top element, and it will swap, right? So and then it will swap. So if we swap, so what is the formula here we have? So grid of x plus j of y plus I. So that should be equal to grid of 1 plus 0 of 1 plus 0, right? So x is what? 1. J is what? 0. So y is what? 1. I is what? 0. So the value of this should be equal to grid of 1 of 1, right? So grid of 1 of 1. So that is what equal to 1 of 1 what we have? 1 of 1 we have 6. So here the value is 6. This is top element. So this is what? Top element. So this is top element. So our top element is 6. And what is our bottom element in that index? So our bottom element is equal to grid of, so what is the formula? Grid of x plus k minus j minus 1 and y plus I. Right, so this is our formula for our bottom. So if you write those values, so grid of, what is my x value? That is 1. So what is my k value? K is 2. So what is my j value? 0. So what is my I value? I is also 0. Sorry, it is 1. So 1 and then what is my y value? 1. So what is my I? That is 0. So if you write the element, so grid of 2 of 1. So what am I having my grid of 2 of 1? So 2 comma 1 what am I having? That is 10. So 10. So my top element is now 6 and my bottom element is now 10. So now we are going to swap this top element and bottom element. So if you swap, 6 comma 10, so what it will do? So it will go here and now in my 6 top element, the bottom element will be occurred. And in my bottom element, the top element will be swapped. So now it will be 10 and then in my bottom place it will be 6. So my submatrix now will look like 10, 6 and then 7. In my bottom it will look like 11. So after the first swapping, my submatrix will be look like this. So then the iteration 2 will be happened. So the iteration 2 will be happened. So now I will equal to 1. So I already said we have only 2 iteration for I and 1 iteration for j. So now the I will be equal to 1. The second column inside the submatrix, right? The second column. So this is the 7 and 11. So this is the second matrix, right? The second matrix inside the submatrix. So if you see the column index the column index will be y plus I equal to 1, then plus 1, that should be equal to 2. So y is 1, I equal to 1, so 1 plus 1 equal to 2. So now the j is equal to 0. So what is my top element? My top element would be grid of 1, 1 of 2. So if here we calculate top element, what is x? 1. J is what? 0. So 1. So and what is my y? My y is 1. What is my I? My I is 1. So 1 plus 1, that should be equal to 2. So here I am writing grid of 1 of 2. What is my element? So 1 comma 2, what I am having? That is 7. So my top element is 7. So my top element is equal to 7. Then what is my bottom element? That is grid of 2 of 2. So how I am writing a grid of 2? So if you calculate here, so what is my x? 1. So k equal to 2. So 3 minus j is equal to 0. So 3 minus 1 is 2. So I am writing a 2. And then what is y? 1. And what is I? 1. So 1 plus 1 here 2. So what is my 2 comma 2 value in my submatrix? That is 11. Right? So that is 11. So now again what will happen? Swap 7 comma 11. So if we swap here, level will be replaced and in my bottom 7 will be replaced. So at final the submatrix has reversed. So at finally our submatrix will be 10 11 and then 6 7, right? So what we are doing? So first, so this for loop is for outer loop and for columns. So this inner loop is to swap the bottom and top. So result what we are getting? So vertically flipping the submatrix. So I hope you understood. So we run this code. So the test case have passed. So we try to submit this. So it has run in 100%. So if you see the time complexity of this problem, so the time complex will be our outer loop. So our outer loop is running for k times, right? So the outer loop is for running k times and my inner loop is running for k divided by 2. So if you calculate time complexity, it should be equal to, we go of k into my k divided by 2. So that should be equal to k into k. And finally our time complexity will be k square. Right? So our time complexity will be k square. So our space complexity will be, we didn't use any extra space. We just swap in our own grid. So our space complexity is constant. That means big O of 1. Understood? So what are the key concept in this problem is? So this is the matrix manipulation which uses in-place swapping. So the concept is similar to reversing the array and flipping the matrix vertically. So we are just taking the k into k block and flip it upside down column by column. So I hope you understood this problem. If you have any doubt, let me see in the comments or chat. So if you like this video, please subscribe. So thank you for listening. We see you in our next video.